We discovered our controllers with the who is. And so we're going to start by programming the VAV controller. So going back to your client numbers, let's go up here. So Jason's got his. Let's just go here. So Jason, you can be 116.102, and then you'll be 18.102 and 95.02. That'll be the three controllers that you can program with. And then Colin, you'll be 116.103, 18.103, 95.03. And then Royce and Corey, you can be 116.104, 18.104, and 95.04. And then I'll be 116.105, 18.105, and 95.05. So that means in your discovery list, let's see, let me go back here and here. I'm going to discover my controllers. And so I'd mentioned that you can actually sort by any of the columns. I normally sort by the device column, but there's a term called MAC address that we'll talk about briefly here in a minute. This is the different IP connections. So there's each IP address has a 9540 programmable controller, a rooftop controller that starts with 18, and a VAV controller that starts with 116. And so that's you'll see when you sort by IP address, there will be one type of each controller. Talk about network numbers more with the ASIC 3s, and max APDU, I don't think you normally need to worry about that. So following my list, and I am going to double click on 116.105. And then it will, when you double click on it, it reaches out and asks for more information from the controller, including its model number, its ASI address, its firmware version. There's also a 32-character description in the controller. And then this is the communication path. So it's we're basically putting ASI programming messages into a BACnet packet. And then this is the IP address and the port number. BAC0 is that port 47808 that you normally see for BACnet IP. 9505 is the network number. 12 is the MAC address. And then device ID is the BACnet address. So if you click OK, then it should upload information out of the controller and show you an opening screen. You may get an occasional comm error. I think that's just all of us talking on the network, and the controllers are actually doing some data exchange as well.
Hey,
so in ASI Expert, you'll see a series of tabs. Yeah, go ahead.
When I click on mine, it just says configuration of this device type is not supported.
I've got the same thing.
Huh, that's interesting. Huh, that's interesting. Let's see. Let's make you the presenter. So yeah, go ahead and share. Go ahead and click OK. Double click on let's see, double click on 9504 and let's see what you get. Oh, interesting. Click OK. Go back to the network button. Do you have the remote? There's a checkbox there that needs. Yeah, you don't have the on private network box checked. Put a check in that box for on private network.
On private.
Right next to 47808.
Oh, okay.
Yeah. Then hit OK. Go ahead and hit who is again. Okay, and then once it turns black, then you're going to be what, 116.104?
Yeah.
Yeah. Try to double click on 116.104 now.
There we go.
And then Colin, let's take a look at yours. Go ahead and share your screen.
Yeah.
Oh, yours is good. Okay. All right. So everybody's good there, I think. So let me share my screen again. There we go. So the opening screen that we show you, and there's a series of tabs up at the top. And these, we show you the BACnet settings and this MSTP checkbox as the opening screen because that's an important thing you need to set or be aware of is whether it's talking ASI protocol or BACnet protocol. So by default, the controllers you ship MSTP enable is no. They default to ASI protocol. Once you set MSTP enable to yes, and the checkboxes, the text describes the current setting of the checkbox. So checked means yes. If I were to uncheck it, and I don't want you to, if I were to uncheck it though, it would say no. So just be aware that the text changes as the text box is, toggled on and off. And so the rest of these settings are all BACnet related here. There's some color coding that ASI expert follows. Anything with green is stored in what we call non-volatile memory, which means the controller will remember that upon reset. And that's something that you usually can set when programming the controller. Anything that's in purple is stored in dynamic memory. That means it's usually something that you don't set, and the controller will set it kind of on its own. They normally reset to 0 when the controller first powers up, and then the controller will update those values on its own. Those are usually not things that you change as part of programming the controller. So the MAC address for BACnet MSTP is like its local network address. It can be between 0 and 127. Each controller on the same MSTP network needs to have its own unique MAC address. MAC info frames has to do with, MSTP stands for master-slave token passing. So there's this imaginary token that's getting passed between the controllers. And the max info frame setting has to do with when the controller has the token, how much communication can it initiate on the network. And ASIC ones don't actually initiate any of their own communication because they don't do any independent data sharing. Max master is, it should be the highest of the MAC addresses of all the controllers on the network. They usually default to 127 because that's the highest MAC address you can have. And they usually actually stay at 127 in practice, just because if you leave them at 127, then that setting will never be a problem. If you set it too low and you add a controller with a higher MAC address, then that can cause a problem. So usually people just tend to leave them at 127. The baud rate needs to be common between all of the controllers on a MSTP network, and we default to 38.4. You can go as high as 76.8, and I think in a future firmware release, 115.200 baud is now also supported by BACnet. So if you want to go faster, you can. 38.4, I think, still seems to be the most common one I see. And then the BACnet device instance is its BACnet address, and it can be between 0 and a little bit more than 4 million. So it shouldn't be too difficult to find a unique address, but when working on a BACnet system, it is important that you know what all the BACnet addresses are, so that if you ever add a controller, you don't add a controller with a duplicate address, because that would cause a communication problem. So I'm going to skip past the BACnet values tab for now and go to the status tab. And so the status tab, notice a lot of these, in fact, all of them are purple. So this is, except for the description. So these are all just kind of monitoring values. So you can see what the current temperature reading is, the zone temperature, the control mode. It can be deadband heating or cooling. The control state can be off, on-off, or night setback. There's also a morning warm-up that can be used. So let's go back to the slides. So we've discovered the controller. This is just a slide about making a direct USB connection to an ASIC 3 for Windows 8, because it had some weird quirks, but not many people use Windows 8 now. We talked about the MSTP checkbox. No means ASI protocol. Yes means talk with MSTP. If you do change any of those settings, the reset button's there because it does require a reset. And then pressing that button does a soft reset, similar to if you've quickly cycled power to the controller. So back on one of the earlier slides, it said that one of the first things you want to do is select the personality for the controller. And so you can find that setting on the Configure tab, and then when you click on the description of the current personality, it will show you this list. And so if it says VAV, that means not a fan-powered box. If it's a fan-powered box, you can either choose intermittent or constant fan, depending on the way, what type of fan-powered box it is. So what we call intermittent, some people think of as parallel fan-powered boxes. And what we call constant, some people think of as series fan-powered boxes. And then after that, there's the reheat selection. So for VAV personalities, we can have 1, 2, or 3 stages of electric heat. Notice for the fan personalities, we can only have 1 or 2 stages, and that's limited by the number of digital outputs. There are 5 digital outputs. Let me just go back so you can kind of visualize a little bit. Go to the picture of the controller. So if we were to look here, there's 5 digital outputs. 1 and 2 open and close the damper, so those are reserved. Output 5 happens to be the one we use for the fan. So if we're already using 3 of them for the damper and the fan, that only leaves binary outputs 3 and 4 left for the reheat options. And so that's why we only allow up to 2 stages of electric heat. And so if you want to see that screen, you can go to the Configure tab in ASI Expert. And so the personality is shown both as a number and as an English description. So if you click on the English description, that's where you'll see that list from the slide. And so by default, this is VAV cooling only. That means it's just trying to position a damper without reheat, where output 1 opens the damper, output 2 closes the damper. And so that's fine for our initial kind of examination of the controller. One of the other bullet points in programming was the state schedule. And so this is what the state schedule screen looks like. And there's different times for different states for different days. So by default on weekdays, we go to occupied at 7 a.m. We go to night setback at 7 p.m. And on weekends, we're just at night setback all day. If you want to change those times, you can change them by just clicking and entering a new value in 15-minute intervals. Where it says not used, you can enter a value of 0 because 0 is not a valid value. It just means basically ignore that state. And so 12:15 is the first valid time in a day. So that's why on Saturdays, Sundays, and holidays, we have it set to 12:15 a.m. So that's night setback all day. I mentioned that ASIC 1 controllers don't have a hardware clock. And then for backnet cases, usually in a backnet case, there's a backnet front end that has a scheduler, and that's getting used to tell the controller whether to be occupied or unoccupied. And so there's this checkbox called State Schedule Disable, and unchecked and no means follow the internal schedule. If you put a check in the box so that it says yes, then it will ignore its internal schedule and just take commands from an external device, whether it's the front end or a supervisory controller. So to see the state schedule disable, I can see here is checked and yes, and you can put a check in the box if yours is not. And then you can also see that by going to other values and state schedule, so that the default tabs we show you are for values that we think you're going to look at most frequently. And then other views lets us get at some screens that we think you'll look at less frequently. So state schedule is one of those. So if you click on state schedule, here's the screen that we're showing you. So you can set state schedule disable to yes if it's not already. If you were using the internal schedule, just as an example of changing the time, we started at 7:30 a.m. So for Monday occupied, if I wanted that to be 7:30, I could just type 730. I don't really need the colons or the AMs. You certainly can, but I usually just type it in as a numeric entry, and then the software will interpret that correctly and put the right number in there. We're going to end probably about 1:30 p.m. today. So if I was using this schedule and I wanted 1:30 p.m. for night setback, you could either type 1330 in 24-hour format or 1:30p. Those would be the two ways I would enter it. It's always going to display it in its preferred format, but it will accept entry in a variety of formats. So that's that slide. Temperature set points are on the configure tab, back where the personality was. So each of the three main states, occupied, unoccupied, night setback, has its own independent heating and cooling set points, where the cooling set point usually would be higher than the heating set point. The default, 72 heating, 74 cooling for the occupied set point. And then for unoccupied and night setback, we spread the set points a little further. And every 30 seconds, we're going to compare the zone temperature to the set points and then decide if we should be in the heating mode or the cooling mode or deadband. So if we're higher than the cooling set point, then we go into the cooling mode. If we're lower than the heating set point, we go into the heating mode. And if we're in between the heating and cooling set points, then we'll be in deadband. And so if we look at our controllers, at least my controller, my temperature is between the heating and the cooling set point, so it happens to be in deadband right now. So going back to the status tab, there are heating and cooling requirements shown, and those are in percentage between 0 and 100%. So in deadband, both the heating and the cooling requirement are 0%. If we go into the cooling mode, then every 30 seconds, we'll run a PI calculation to update the cooling requirement. If we're in the heating mode, every 30 seconds, we run a PI calculation to calculate the heating requirement. And the PI calculation is, you've probably heard of the term PID. It's just the PID calculation without the D. And usually you don't need the D for HVAC cases. So to see our controller start doing something, we're going to lower our set point to get at a deadband, and I want to go into the cooling mode. So to get into the cooling mode, I either need to lower my cooling set point or raise my temperature. So I'll just lower the set point. So if I've got 73 degrees here, then on the configure tab, I'll set the cooling off temp SP by clicking. I'll enter 72, and then I'll make the heating set point 2 degrees lower at 70 degrees. And so once you change the cooling and heating occupied set points, then the active heating and cooling set points should change here as well. The controller should recognize the change in the occupied set point, say, oh, I'm in occupied, so I'll change my active set point. And so now on the status tab, every 30 seconds, and that's when the seconds in the top right-hand corner shows us the day of the week and the time. When the seconds is at 0 and the seconds is at 30, then it can update the heating or the cooling requirement. So I can see there your cooling requirement may be a little different. It depends on the difference between the temperature and the set point and how long. But my cooling requirement went from 0 to 5.9%. And if you go, let me just go to the slides. I think we'll go to the primary airflow. Yep. So there's a primary airflow tab that will show us the airflow input, and we don't actually have any. We're not, connected to a VAV box with these training kits. They're just in our rack. So we're not going to actually be measuring airflow. But on the primary airflow tab, you would see the primary airflow input value, the calculated set point, and then whether the damper is opening or closing to try and meet that set point. So on the primary airflow tab, one of the things you can set while you're doing the initial programming is the primary duct area, and that's in square feet. So the default is 0.35 square feet, which would be the duct area for an 8-inch round box. And so the primary airflow set point in heating and deadband, just at the minimum, you can see here, there's some green settings for cooling min-max airflow, and on the right side here, there's heating airflow min-max. And then in the cooling mode is when we're actually start to see the airflow set point ramp up. So as the cooling requirement goes from 0 to 100%, the primary airflow set point will ramp from min set point to max set point. So now I'm at 23.9%, and again, your number may be different. But on the primary airflow tab, now my primary airflow set point is 219 CFM. If you did the math, 23.9% of, well, now it's a different number. What are we at? 30%. If you did the math, 30% of 70 to 700 would be about 263 CFM. And since my measured airflow is much lower than my airflow set point, then the damper's opening, meaning that output number 1 is on. As the airflow approaches set point, we'll actually start pulsing the output a little bit so that we try not to overshoot the set point. And so the goal there is to reach set point and stop. So at kind of a basic level, if we're lower than, if the airflow input is lower than the airflow set point, we open. If the airflow input is higher than the airflow set point, then we close. And at a simple level, when we reach set point, we stop, but it will do some pulsing as it approaches set point so that it doesn't overshoot, or at least doesn't overshoot too much. And so that's what we do here. So every second, we're comparing the airflow to the set point to decide what to do with the output. This hysteresis is used a little bit. It's kind of a deadband. So if you change that hysteresis amount, then it affects how it handles the pulsing as it approaches set point. And then there's an air balance screen that can be used to kind of help the controller measure the airflow more accurately. So the airflow sensor itself is calibrated at a 0 point, but then, depending on the performance of the flow cross and whatnot, there's this K factor number that can be changed. And so what we normally do to get to this air balance screen, there's actually 2 ways. On the status tab, there's this air balance view button. And on the other views tab, there's this air balance button. They both get you to the same screen. And so what you would normally do is click the cooling damper override action and force the cooling damper to max CFM. And then it should start trying to control the max CFM. You normally do that for every box that's being served by a specific air handler. Let them settle out, and then up here, this ASIC 1 airflow tells us what we're measuring currently. And then if you measure the actual airflow with your hood, you can use the ±5 buttons so that the value in the green box matches what you have measured. And then the controller will, or the software actually will automatically update this K factor to make those numbers more equal. We don't recommend that you change the K factor manually to kind of calibrate the value, because our controller, the airflow set points are actually stored in velocity, and we calculate those to CFM in software based on the K factor and duct area. So if you were to adjust the K factor or duct area after you'd set the airflow set points, it would actually shift your set point. If you use our air balance screen, then what the software does is it captures the airflow set points, makes the adjustment based on your ±5 button entry, and then it resets the set points back to where they were. So the order I would normally do things is set my duct area, then set the airflow set point, and then finally use the air balance screen to make sure that the airflow reading itself is accurate. Once you're done with the air balance and you want to go back to automatic mode, then you can go back to the cooling damper OR action, and then restore cooling damper means clear the override. And so right now you can see it says override maximum, but once I click restore and OK, then it probably will start to open because my airflow is going to be lower than my set point. And then once you're done with the air balance screen, you can click on the configuration view button and it goes back to the normal programming screen. So that's air balance. And so that brings us to reheat. And so for a single stage of reheat, if we chose that personality, then there's a heating tab. And there's this electric heat minimum airflow set point that we're going to want to set to 0 because that value normally says what's the minimum airflow that I need to measure before I allow the electric heat to turn on. And since we're not measuring airflow, if we set that to 0, then it basically disables it. Output number 3 is used for the electric heat, so we'd wire that to our contactor or relay. And then we'll turn on the electric heat output for a fraction of this electric heat base time, which is in seconds, based on the heating requirement. So if we were at a 25% heating requirement, then we would turn on the electric heat output 60 out of every 240 seconds. If we got to 75%, we turn it on for 180 out of every 240 seconds. So to see that work, we can change our personality to VAV with one-stage electric heat and change our electric heat minimum airflow set point to 0. So I'll switch back to ASI Expert. Notice the heating tab is not shown here. That's, you can find it from other views. And then here's heating right below state schedule. And so notice that all these values are grayed out. There's a script running in the background that hides and shows different settings depending on what the current selections are in the controller. So I'll go to the configure tab, and then here where it says VAV cooling only, I'll click, and I'll choose VAV with one-stage electric heat and click OK. I get a prompt, do I want to reset the device? And I'll say yes. And then as it uploads the tables to check to make sure it has the latest settings, then it'll start running with our new setting. And so now if I go back to the heating tab, I can see that some of the electric heat items are not disabled anymore. So the electric heat minimum airflow set point up at the top, I can click on there and then highlight the old value, type in the new value of 0, hit OK. And then to actually see the heating output turn on, I need to get the controller in a position where it wants the heat, meaning that the temperature is lower than the set point. So another way, I showed you, I certainly could raise the set points, but another way to do it would be to lower the temperature. And there's actually a calibration point for the zone temperature input that you can enter plus minus 10 degrees in. So I want to lower my temperature by about 4 degrees so that my temperature is lower than the heating set point. So if you go to other views and input summary, there's this zone sensor bias above the zone temperature kind of top center. And it probably has a 0.0 value in right now. If you click on that, it shows you can enter a value between the min value of -10 and the max value of +10. So I'll put in -4. And then my zone temperature will go down by about 4 degrees, which should be lower than my 70-degree set point. And it is. And so now if I go to the status tab, to get out of the cooling mode, the cooling requirement needs to ramp down to 0, and the temperature needs to be 1 degree lower, at least 1 degree lower than the cooling set point. So there I just went to the 0% cooling requirement, which allowed me to go into the deadband mode. And then at the next 30-second mark, I would expect it to go into the heating mode, and then the heating requirement will start calculating. So now I've got the heating mode, and then at the next 30-second mark, the heating requirement will update. I'm going to do other views and heating again. And So I think the timing will work out pretty good. I should get into a non-zero heating requirement by the time this resets back to 0, and then I should see the heat turn on. Flip over to status. Okay, so there's 3.5. I'm just going to bring up my Windows calculator just so we can kind of show you 240 times 0.035. So it only want to, at 3.5%, it would want to be on for the first 8 seconds. I think it'll go up at least one more time because we decide to turn on when the electric heat timer starts counting back from 0. So let's see, it'll go up one more time. It was 3.5%, now it's 7.1, so 240 times 0.071, 17 seconds. Flip back over to the heating tab. Actually, I think we'll get one more update because it's at 30 seconds. Then that will start at 240. Actually, you can see it on the status tab. You can see the timer and the heating up here too. So that's actually fine. And then we can see the heating requirement. So now it's 11.4%. So we'll see electric heat should turn on, and it is. And at 11.4%, it should be on for about the first 27 seconds. And so the electric heat timer's counting up. Electric heating 1 status is on. And it may go up one more time. Let's see. Yeah, I think it will. Let's see, 240 times. Now we're at 0.153. So at about 36 or 37 seconds, I would expect the heating 1 status to turn off based on my settings in my controller. So there's 37, there's 38, there's off. So it turns on for a fraction of the base time according to the heating requirement.